All we want to do here is solve for y. In other words, get y by itself. So we're going to think of m, b, c, and d, these just as numbers. So here we have y multiplying some number and divided by some number. I'm going to get y by itself. So the first thing I'm going to do is I'm going to get rid of b by multiplying it over. B is just a number, so think of it like division by 2. To get rid of a 2, you're going to get multiplied by 2 to both sides. So that's going to give me sorry, not 2, b, which is what we're multiplying by, not 2. So the b's are going to cancel on this side, and we're going to get ym equals c over d times b, which is the same thing as cb over d. Same exact expression. Doesn't matter which one you use. So here we're going to get y by itself. By now, if this was multiplied by 3, for instance, if you had 3y, to get rid of the 3, you would divide it out. So here we're going to get rid of the m by dividing it. So we're going to get y, those m's are going to cancel. We're going to get c over d times b over m. This is another expression as I did before, cb over d divided by m. You can also multiply by the reciprocal here. It's going to be cb over d times 1 over m, which is going to give you cb over dm. So all of these expressions are the same thing, and they're all valid solutions. I would say probably this last one gives you the clearest answer because it uses the simplest form, in my opinion, the simplest form of the expression. But they're all equally valid. Now, instead, you could also solve this immediately for the first step by multiplying. I'm going to multiply by b over m right off the bat, because that's going to cancel with the b, cancel with the m. I multiply by b over m here, and you can see we're going to get c times b over d times m. That's the exact same expression that I had in the end there. So it's a quicker way of doing it. If you don't see that, that's fine. All right, here we want to solve for EA. That's just this term. We're solving for the entire EA term. EA is a variable. It's not 2 variables, E and then A. It's EA is the name of that variable. The same thing is true for EQ. This is just a single variable here. So I could replace that with X, for instance. And I would get, well, if I replace EY with Y, I would get Y minus X over R. And I'd be solving this for Y. It's the exact same solution for both of these. I just replaced the variables. So don't get that confused. Okay, let's solve for EA here. I need to get rid of this to fraction because I want to get this unlocked. So like you can think of this as in parentheses because that's what a fraction bar does. So to get rid of parentheses, we can either distribute the R if you want, or we can multiply the R over to the other side, and that will actually get rid of the parentheses for us. So I'm going to multiply by R on both sides. That's going to give me R times I, or Ri, I'll just write it as Ri, equals EA minus EQ. Okay, now I need to get EA by itself. I can just do that by adding EQ over. So I get Ri plus EQ equals EA. And EA is by itself, so we have solved the formula. That's what EA equals. You can, of course, do this in different ways. If you were to distribute the 1 over R, you get something like I equals EA over R minus EQ over R. I can add this term over to the other side. It's going to give me I plus EQ over R equals EA over R. And I can multiply both sides by R. And then distribute it in there if I wanted to. I get Ri plus R and R cancel, and we get just EQ. The R's cancel here, we get just EA. So we get the exact same expression. I'm just doing it a little bit different. You can, of course, also just leave it like this. This is also a valid form, but I wouldn't say that's simplified because we can actually get rid of this R here by distributing it in there. But they're all valid. So just make sure you understand how they're all equal to each other. For this one, we need to get K by itself. The issue is that we have 2 occurrences of K. However, they're both on the same side, and we can get rid of that by factoring the k out or undistributing it. It's the exact same idea. So if I were to take a k out of there, I would get k times r minus l. I'm factoring out the k. I'm undistributed in front. And you can always check your work here, right? If I were to distribute this back in, k times r, k times l, I get k times r minus k times l. I get the same thing. I haven't changed anything by doing that. Okay, the reason why this is important is because now we can get k by itself. K is multiplying by this just some number, right? R and L are just numbers. So if you have a number multiplying the variable you want, divide that number out. And then you're going to divide to both sides of the equation. Those, of course, cancel, and we get left with k equals f divided by r minus l. I think that's a valid way of doing that. You could, there's not really a better way of doing it because you do need to undistribute it like I did here, or factor it out. And the best way of doing it at this point is just go ahead and divide it over. So I think that's probably the clearest way of doing it. I can't really think of another way of doing it, but there probably is another way. It's just, it's going to be equal to this one though.